Welcome back, everybody. This is going to be the part one of our homework review for lesson 34, solids and their cross sections. This is going to be a little bit different from what we had before, ladies and gentlemen, because most of the time we did area two-dimensional, and now we're dealing with three-dimensional figures. So we'll do the best we can with our pictures and hopefully describe the shapes, if you will. So let's begin. Number one, the following figure has faces that are all triangles. It would be classified as which of the following solids? Either choice 1, a prism, choice 2, a pyramid, choice 3, a cone, or choice 4, a cylinder. Now, a cylinder it cannot be because, cylinder is basically going to be a figure, a three-dimensional figure where you have, it basically has two parallel faces that are circles, and we call the lateral side or the surrounding side it will be just kind of like again it's a rounded type of thing. And so definitely not a cylinder because you have all of these are polygons, so no circles here, so definitely not going to be choice 4. As a prism, we define prism in this case. So let's get to our definition of prism. Our definition of prism is going to be the following. A prism is a solid geometric figure whose two end faces are similar, equal, and parallel rectilinear figures, and whose sides are parallelograms. And so, well, this figure does not have that, though. It doesn't have two congruent polygons that make up basically the bases, if you will. And so, not two, just one base in this case. So that would be not a prism, so not going to be choice 1, and not a cone, because although the pyramid and cone has share a similarity, the idea is that both the pyramid and cone do have a base, and the kind of all the sides meet to one point, except for a cone is a base of a circle, not the base of a polygon. Therefore, not going to be a cone, is going to be a pyramid. Now, you can have pyramids that are going to be, in this case, we'll have in this case to be whether or not triangles, it could be polygons. A pyramid can have a base as any polygon, all right? Just not a circle. So here, it's just the fact that all the lateral sides kind of meet to one point instead of meeting to a parallel side. So, okay, so that's question number 1. Question number 2. If a rectangle is revolved around one of its sides, the solid produced is going to be, well, which of these 4? Sphere, prism, cylinder, or cone? Well, let's take a look at our basically coming up with a rectangle. So let's take a rectangle here, ladies and gentlemen. So here's a rectangle. And we're going to rotate this rectangle about one of its sides. And so we're going to pick, in this case, this side here. If you rotate around and making this the axis, if you will, it's kind of spinning around, you're going to get kind of a circular figure here. This is going to look most likely like not a sphere, not a prism, because again, no polygon basis, and not a cone, but going to be a cylinder, okay? So you have to kind of imagine this case, kind of draw the figure, if you will, helpful to get these things. So question number 3, which the following must be true about the faces of the following prism? Okay, now there are total 5 faces. Actually, that's not true. We have, in this case, the top and the bottom, that those are 2 faces, if you will, and then 5 along the edges. So there are 7 faces here. So this is why choice 1 is no good. All non-pentagon faces must be rectangles. That would be sort of true, except they're kind of tilted, though. We see in this case that the sides are parallel, but they're not going to be forming a right angle, so not going to be rectangles. All right. Now, there's only one pair of congruent faces. We don't know that for sure. We do know in this case it could be that definitely the top and bottom are congruent faces, but the sides could be congruent. We don't know, so must be true. It has to be true all the time. So we cannot confirm that. We do know that 5 of the faces are parallelograms, and those are these here. Because again, back to a definition. Okay. A prism is a solid geometric figure whose 2 end faces are similar, equal, and parallel rectilinear figures, and whose sides are parallelograms. And so these lateral sides here, each of these sides here are parallelograms. Now, so why not rectangles? Well, they're kind of tilted. And so you got a prism that's not necessarily going to be from a right angle. That's to be a right prism. No, these are not necessarily true in this situation. Okay, so, all right, so that's the definition. And so now question number 4. If right triangle ABC is rotated about segment BC, then the solid produced would look like the following. Okay, well, definitely not like a cylinder. Okay, if it was a rectangle, it'd be a cylinder. Okay, and we're rotating about this axis here. Okay, a rectangle would be a cylinder, so definitely not going to be this one or this one because we don't have a rectangle. Instead, what we have here is that we rotate about BC, we're going to get a circle here, but coming up this way. And so we're going to get a cone, but specifically the cone, because we're rotating about BC, not about AB. If it was AB, it would definitely be this one, number 2, but that's not the case. Instead, we have choice 1 best representing our picture here. Well, I know in this case it's probably a good idea. Again, draw the figure and kind of twirl around, if you will, see what it looks like. You gotta start thinking things in 3 dimensions. We actually do a lot of this later on in calculus, and I think a lot of you will be taking calculus, whether in high school or in college, and so be able to picture 3-dimensional figures is a good idea of just being able to how we come up with these shapes, if you will. Okay, question number 5. Which of the following shapes would not be a cross section of a cone? So let's come up with a cone. So a cone would have a base that's a circle, so it's oval, if you will. So here's our oval base, okay, and it's going to, in this case, end up meeting end up meeting at a point on top. So now a cross section would be, in this case, is kind of like, imagine this is a cone-shaped cake, And so if we were to take a knife and to cut the cake in a particular way, cutting down, depending how we cut it though, if we were to separate the piece, what would we have? Well, if you were to separate this, going parallel to the base here, what you would find is that you would get a cross section that looked something like this. I hope I can make this look okay. Let's go move it up a little bit just where the dotted line is. Okay. So what comes down to is that this cross section would look like a circle. So we cut it parallel to the base, we'd definitely get a circle as our cross section. Take off the cone, the very top part would be a circle we look down on. So definitely this is, now the key word is like, well, that should be the answer. No, we're looking for not be a cross section. So it could not be this one. Now, if we were to come down perpendicular, in this case, say coming this way, say using a cutting across this way, if we were to, let me just remove this now, delete this and delete this. Okay, what if we were to come down, like if we had a rectangular cutter, all right, just a rectangular cutter, let's say a rectangular cutter and, like, you know, cut down this way, right straight down the middle. Okay, so we did that. Well, if we cut down straight from the very top, we would find that it would look like a triangle, that we separated them. The 2 pieces would be, well, if you looked at straight forward, it would look like a triangle. So we could get a cross section that would be a triangle here. So that could be cross section. Now, what if I move this rectangle so that it was not necessarily going to be, let's see now, let's take a look here. Maybe if I use the dotted line, maybe I should use it to kind of show this. So if our knife went down, again, this way, down dead center, okay, down dead center, and we separated, we would get this triangular figure here. But what if we instead did not cut down dead center from the top? What if we moved the knife somewhere over here? Well, if you did that, what we would have as we separate this piece here from this piece here, the right piece from left piece, we would get a showing of choice 3. So choice 3 would end up being the cross section here. So the one part that would not be cross section would be choice 2. So choice 2 we could not be a cross section from a cone. I would say in this case it could be cross section if we were to cut a rectangular cake and cut a piece, and you would see the section that showed would be in this case a rectangle, but here not for a cone though. Okay, all right, ladies and gentlemen. So the idea of a cross section. Again, you watch certain shows, people cooking shows especially, they, like, for example, they'll make something, especially like a sandwich or something like that, or a burger or something. They'll cut the food down the middle and separate. And what they're doing is showing the cross section, if you will, of the inside part. And that's really what we're doing in this case. If I separate or cut a piece off and show the inside part, what shape will we have? And so that's sort of what we're seeing here. All right, ladies and gentlemen, hopefully this is helpful to understand some of these questions. Again, not a lot of work shown, but I do think drawing diagrams does help to kind of visualize things. The key thing is you want to visualize, and it's hard to do on a 2D plane to do three-dimensional material. So, but I hope this was helpful, and if you've found this video helpful, please leave it a like. Leave a question or comments in the section below. Any suggestions, we really would love to hear from you. And also in this case, if you like to go suggest, hey, Mr. Gong, can you do a topic that maybe that's before this null, maybe help out, let me know. This way I can maybe do a video just on that particular topic as well. All right. Thanks so much for watching. I hope that you guys are doing well. Take care and be safe.